This section is all about generating patterns, equations, and graphs. So it's the process, it's the thought process in this section that I'm hoping that you guys will kind of carry with you throughout this quarter as we go through to try to work on developing equations and how we can use those equations to also demonstrate and show graphs and how the two kind of work together. So my hope is in this section what you'll do is you'll notice patterns, and then you'll take a look at how can this pattern how can it be translated into an equation, because equations can be extremely useful when we're trying to make predictions, because doesn't always make a lot of sense to create a table and then extend that table. Maybe you start the table at 1, and you have to sit and extend that table all the way out to 100 in order to get your answer. So hopefully we can come up with better methods by developing equations for these things. All right, so in this first problem here, it says the table below shows the relationship between the number of kites in an arrangement and the total number of ribbons on the kite's tails. Describe the pattern in the table. How many kites could you make with 275 ribbons? Explain your answer. So what they're trying to get you to do is they're trying to get you basically to recognize that this situation can be translated into a table. So if I wanted to just look at the numbers, I can generate this type of situation where I have, so this is the number of kites. I'm just going to label it with a K. And then this is the number of ribbons. I'll label that with an R. And then what we could do is we could organize our information by saying we have 1 kite, we have 5 ribbons, we have 2 kites, we have 10 ribbons, we have 3 kites, we have 15 ribbons, and hopefully you're noticing a pattern. Hopefully you're seeing that, all right, as my number of kites increase, take a look at the ribbons. So as my number of kites increase, my number of ribbons is increasing by 5. So if I wanted to continue this pattern on, oh my goodness, if I wanted to go all the way out so that my number of ribbons was 275, I would have to work on this pattern for quite a while. So I'd have to go to 3 and then 4 and then 5 and then 6, 7, 8, 9. I would have to work on this for a long time. It's just not feasible. It doesn't make a lot of sense. So that's why what we're trying to do in this section is we're trying to get you to recognize that we can take patterns and translate them into equations. And then we can use those equations. Those equations can be extremely helpful when trying to make predictions or when we're trying to make these crazy calculations to figure out how many kites do I need for 275 ribbons. All right, so the essential understandings here. Sometimes the value of one quantity can be found if you know the value of another. And that's why we're organizing our information into tables, and then we'll use our tables to help us come up with equations. So you can use an equation with 2 variables to represent the relationship between 2 varying quantities. A solution of an equation with 2 variables x and y is any ordered pair. So what we're trying to do is we're trying to just start off with the basics of a table. So here's my table, and we're just starting with the basics of it. So the first thing we're trying to do is we're trying to take this equation, y is equal to 4 times x, and we're trying to determine if this right here, this is called an ordered pair, we're trying to determine if that ordered pair is actually a solution. Does it make it true? This is just an open sentence, so we're trying to figure out if that makes it true. Well, just a refresher on ordered pairs. Ordered pairs, when I have an ordered pair, this 3, 10, what that's telling me is that my x is equal to 3 and my y is equal to 10. Every single ordered pair always goes x, y. So in this situation, we're saying that x is 3, y is 10. So if my equation was y is equal to 4 times x. Is that a true statement? When I substitute the numbers in and I do my calculations, I find out that it is not a true statement. So since it's not a true statement, we know that this is not a solution. All All right, so that's all they're trying to do here is they're just trying to get you to analyze this and figure out if these ordered pairs are actually solutions or not. So we could test out this part A. Is part A a solution or not? Well, when I set that up, remember, the second number is your y. So it would go 20 is equal to 4 times x, which was 5. Because remember, it always goes x comma y. So is this a true statement then? When I take the numbers and substitute them in, 20 is equal to 20, so therefore it is a true statement. So 5 comma 20 is a solution to y equals 4x. And now we can test the next one. So negative 5 and negative 20. Is negative 5, negative 20 a solution? Well, when I plug those in, do a little bit of mental math here. Negative 20 is equal to 4 times negative 5, which is negative 20. So part B is also a solution. And then we can test part C and we can test part D just to see if it's a solution or not. So now that we've tested them to see if they're solutions or not, now what we're going to do is we're going to talk about the process of actually setting up those ordered pairs. Those ordered pairs are organized into my table. So you can represent this relationship between two variables in several different ways. We're going to talk about all these ways. We're going to talk about how to organize our information into a table, and then into an equation, and then into a graph. So both Carrie and her sister, Kim, were born on October 25th, but Kim was born 2 years before Carrie. So in other words, Kim's age is going to be two more. Kim's age is going to be 2 more than Carrie's. She is 2 years older than Carrie, so therefore Kim's age is 2 years more than Carrie. See how we're translating that into words? When we translate it into words, then we can usually translate it into the mathematics. So the first part here is just showing you that we can organize some of this information into a table. So if Carrie was 1, that means Kim would be 3. If Carrie was 2, Kim would be 4. If Carrie was 3, Kim would be 5, and so on and so on. So now when I translate that, I could say, you know what? Kim's age is 2 years more than Carrie. Well, when I take that phrase and translate it into the equation, that would come out to Kim's age is 2 years more than Carrie's. So Carrie plus 2. Now when we have these tables, generally the first column represents x, the second column represents y. And that's why when they translate their equation, they put y equal to x plus 2. Instead of using k and c, in algebra generally we want to translate it into x's and y's. So we have our table, we have our equation. Now let's take a look at how we would organize this into a graph. If I want to take this and organize it into a graph, I would take each one of these ordered pairs and then plot them. So my first ordered pair is 1, 3. So just a refresher on how to plot those points. The first number is your x. The x-axis goes across. So the x, this 1, tells me how much to move left or right. The y-axis goes up and down. The second number, the 3, tells me how much to move up or down. So always start at the middle. When I start at the middle, the 1, 3, the 1 tells me to move to the right 1. The 3 tells me to move up 3. So if I do both of those, over 1 and up 3, I'm going to plot that point. So now if I take a look at the next ordered pair, the next ordered pair is 2, 4. So let's take that, and it's telling us to move 2 left or right and 4 up or down. Well, since both of those numbers are positive, it is telling me to move 2 to the right and 4 up and plot that point. And if I keep plotting those points, you'll notice this nice pattern, and it generates this nice linear function is what it's called. It generates this nice line. So now we have completed all three of those. We've made a table to represent the numbers. We've come up with an equation, which will help us if we're going to make a crazy prediction. And then we've come up with a graph. And the graph helps us to to visually see this pattern. All right, here's another pattern that we can analyze, plot and graph, come up with an equation. So here they're asking you to kind of analyze the pattern between the blue tiles and the total number of tiles. So if there's one blue tile, if I count those up, there's 9 total tiles. In the next picture, there's 2 blue tiles. So if I count them up, when there's 2 blue tiles, there's 18 total tiles. So now, when you start to analyze this, hopefully you'll notice that your total number of tiles over here, total number of tiles, your total tiles is equal to the number of blue tiles times 9. So the number of blue tiles, we'll call that B, times 9. And we've just developed our equation. And they normally don't want us to do it in terms of t and b, so let's change those to x's and y's. So this equation right here, if I changed it to x's and y's, I would have y would be equal to 9 times x. So now I have my table, I have my equation, and now we can go through and plot these points, 1, 9, 2, 18, 3, 27. I can plot those points and then sketch in my lines so that I can visualize my pattern. All right, so now the homework for this section. So what we're going to do now is we're going to practice some of this, practice the understanding of some of this. So these do you know and these do you understand, those are always good to review. But we're going to go ahead and we're going to test coordinates. Remember, to test the coordinates, you have to plug them in to see whether it's true or false. So we'll do number 14. Let's do 13 and 14. And then we're going to create a table, equation, and graph. So let's go ahead and do number 20. And then here, the table shows the heights in inches of trees after they have been planted. What is the height of the tree that is 64 inches tall in this pot? So if you want, you can just extend this pattern on, or if you would like, you can come up with an equation and calculate it. Oh, excuse me, use the table to write an equation. You have to come up with an equation in this one, and then use your equation to figure that out. So for number 23, come up with the equation, and then plug that 64 in there and solve your equation to figure it out. And then I thought there was one more that I wanted you to work on. So let's take a look real quick. Maybe that was the last one. Yes, that was the last one. So just those couple problems there. I would like you to finish those up, to work on those and turn those in.